In this video, we will graph sine and cosine using period, amplitude, midline, and phase shift. Alright, several of these problems may not fit on the graph that I have provided, so we may have to graph backwards somewhat. You'll see what I mean. Anyway, problem number 1, it's always good to start with the period. We can calculate the period by doing 2 pi over b. Alright, in this case b is this 3. So 2 pi over 3. That's the period. Alright, so I usually like to put the period right here. So there's my 2 pi over 3. If I go halfway, then that's going to be 1 pi over 3. If this is 2 pi over 3, half of that would be 1 pi over 3, or simply pi over 3. If I go half again, half of 1/3 is 1/6. So this will be pi over 6. Then right here, alright, this position is 3 times this, alright, because this is 1, 2, 3 times this initial amount. So this would be 3 pi over 6, only that's going to reduce, right, because 3 goes into 6 twice. So this is actually pi over 2. So this is how we label. Alright, so again, our period was 2 pi over 3. Now the midline is going to come from this number right here. So our midline is going to be y equals -1. Don't just put -1, put y equals -1. Now the amplitude is going to come from this a value right there. So the amplitude is going to be 3. The amplitude is always positive. Even if this was -3, we would still put positive 3. A negative would mean a reflection over the x-axis, but we'll talk about that later. So this is enough information. We have everything except for the phase shift taken care of. So let's go ahead and graph the skeleton without the phase shift, what I call the skeleton. We're going to use 5 points. So paying attention to the midline, which is y equals -1, let's go ahead and graph that. Okay, so let's put a horizontal line at -1. So there's the midline, the new midline. Now, because the amplitude is 3, and because we're dealing with a cosine function, the cosine function usually works like this when there are no transformations. It starts off high, and then goes low, and then comes back again. So in general, just quick overview, if you have a positive sine function, it starts on the midline, and then it goes above, back to the midline, below, back to the midline. Alright, so it does like that. I would connect these. But if I have a reflection sine function, it still starts at the midline, but instead of going up, it goes down, back to the midline, above, back to the midline. For cosine, cosine starts off above the midline, alright, at the amplitude, and then goes to the midline, below the midline, back to the midline, and back above the midline. Unless it's a reflection, then in which case it would be upside down, and we would start below the midline, then we go midline, above the midline, back to the midline, below the midline. Alright, so in this case we're dealing with a positive cosine function, so we're going to start off above the midline and go down and up. And because the amplitude is 3, we will specifically start off 3 above the midline. Alright, and then we will go to the midline, and then we will go 3 below the midline, and back to the midline, and then once again 3 above the midline. So this is a skeleton of what the cosine would look like, at least one period of the cosine. If it weren't for the phase shift that's about to happen. So, but now we have to do the phase shift. If there was no b value, if this 3 wasn't here, then the phase shift would just be pi over 3. But when there is a b value, the phase shift, to get it, you need to divide by it. Alright, so the phase shift is going to wind up being pi over 3 divided by 3. Okay, you have to take this divided by the b value. Now I know when you're dividing by a single number and you have a fraction, you're just going to wind up doing this. Pi over 3, okay, that's the original pi over 3. If I want to divide by an additional number, it just joins the denominator. So I know it's going to be pi over 9. If you did not know that, then you could think of it as pi over 3 times 1/3, multiplied by the reciprocal. And that would give you pi over 9. Okay, or you could put it in your calculator and go pi over 3 divided by 3 and get pi over 9. Either way you want to do it. So the phase shift is going to be pi over 9, and it's sort of the opposite of this. So it's going to be pi over 9 to the right. To the right. So now my job is to figure out where pi over 9 is on this picture. It will help you to think about the fact that right here would be half of pi over 6 would be pi over 12. Okay, so 1/9 is going to be somewhere between 1/12 and 1/6. Alright, it's going to be somewhere in between there. That means I'm going to have to take each point and move it more than a square over. Alright, I'm going to have to take each point, like this point right here, and move it to somewhere in here. So I'm just going to do that 5 times. So if I take this point and move it more than a square, okay, more than a square to the right, more than a square, and more than a square. Alright, that's going to be a pretty good estimate of what we're dealing with. So now this is the final graph once you have the phase shift, so I can go ahead and do it. Okay, got a little rough in there, but still you get the idea. So that's number 1. 1 period worth. Okay, let's do it again for problem number 2. Alright, first the period. The period is going to be 2 pi divided by the b value, alright, which is 4. So that's 2 pi divided by 4. Well, 2 goes into 4 twice, so that's just going to be pi over 2. So the period is going to be pi over 2. So let's go ahead and put pi over 2 on the graph. That makes this halfway would be pi over 4. That makes this pi over 8. And that makes this 3 pi over 8. It's always 3 times this for this one. So now we've labeled it. Now let's talk about the midline. The midline is going to come from this number right here. So y equals 1 is going to be the midline. So let's go ahead and draw the midline in. Alright, so there's my midline. Now, the amplitude is going to come from this number right here. So the amplitude is 2. I'm dealing with the sine function. So remember that positive sine function, you always start on the midline. I'm going to go up, back to the midline, down, back to the midline, like a snake. Alright, so here I go. This is just the skeleton, so I'm not going to connect these points, but I'm going to start off on the midline, and then I'm going to go up 2, because that's the amplitude, and back to the midline, and then down 2 on the next mark, alright, and back to the midline. So this is going to be my skeleton. Now it's time to shift, figure out what the phase shift is. Do not connect these points, please. Alright, now the phase shift. Alright, if there was no b value, this would be the phase shift right here. But because there is a b value, I need to divide. So the phase shift, is going to be pi over 4 divided by 4. Now I know when I divide a fraction by a single number, it's just going to end up in the denominator like this, pi over 4 times 4. So I know that's just going to be pi over 16. But you can think of it as multiplying by the reciprocal, or you can use your calculator to confirm that you'll get pi over 16. So that's going to be my phase shift. Okay, now because this is plus, it's going to be pi over 16 to the left. And some people like to put negative pi over 16, just indicating that we're going to the left. Okay, so our next job is to figure out how many squares. How big is pi over 16 on this picture? Well, look, there's pi over 8 right there, so guess what? Pi over 16 is going to be right here. Alright, this is pi over 16. So that means pi over 16 is 1 square. So that means I need to move everything to the left 1 square. So I'm going to take each of the 5 points and I'm going to do that. So if I move this left 1 square, it's going to be here. This is going to move here. This one's going to move here. This one will move here. And this one will move here. And this will be my final answer. Okay, got a little dicey in that area, but you get the idea. And there you go. Alright, so that's it for problem number 2. And I think I'll go ahead and stop this video here. So here endeth the lesson.